Hi grade 11s, in today's lesson we're going to find the point of intersection of two straight lines. Now you've done this in grade 10 where you solved simultaneous equations, and it was two linear equations. So it's basically the same, but it can also be tested in this section to determine the point of intersection of two straight lines. Now what's very important when we do this is firstly we need the equations of both straight lines. Now in the past, even in grade 10, you were given that always, but you'll see this differs slightly in some of the examples. And then we solve the two equations simultaneously. Let's look at our first example. Here, this example, both equations are given. It says the sketch shows the graphs of 2x minus 3y minus 4 and x plus 2y equal to 5. Calculate the coordinates of P. And the method I'm going to use for solving these two equations simultaneously is the substitution method. So we just number them 1 and 2, and it doesn't matter which one is called 1 and which one is called 2, it's just to refer to them. So from equation 2, I'm going to make x the subject. That seems to be the easiest thing to do there. Make x the subject. So x is equal to 5 minus 2y. Then I'm going to substitute this into the other equation. So I'm going to replace x in the other equation that I haven't used, equation 1. So substitute it into equation 1. So it's 2 times x. So x is 5 minus 2y minus 3y equal to negative 4. Here we have that equation. Simplified, you get 10 minus 4y minus 3y equal to minus 4. Simplify further, 10 minus 7y equal to minus 4. And of course, minus 7y equal to negative 14. Divide both sides by negative 7. Y is equal to 2. And of course, that's not the end of it, because we need an x and a y coordinate. So we've got a y coordinate, and we can take that y value and we can substitute it here in this equation, because x is already the subject. So let's substitute it in this equation here. So x is equal to 5 minus 2 times the value of y, which we've just worked out. It's 2. If we solve that, x is equal to 1. And let's answer the question right at the end of the sign, which they're asking me for P. So I write down there for the coordinates of P is x is 1 and y is 2. In our next example, the equations of the lines are not given. And so this is different. We've not had examples like this before. It says determine the coordinates of P, the point of intersection of the two lines. The line OP passes through the origin. So this is the line OP and it passes through the origin. So we look at our information here in our sketch. We have a line here which cuts the x-axis at 5, and we have another line here which is perpendicular, and this line OP passes through O, the origin, and it has a point on there. So now we want to determine the equation of these two lines. So we have a line with two bits of information, known bits of information. And so we're going to use those 2 points and we're going to find our gradient. Remember, if we want the equation of a straight line, we need a gradient and we need a point. So we can use our gradient formula and we can subtract the two y values divided by the corresponding difference of the x values. So it's minus 1 minus 0. And I start with this y value, so I have to start with that x value. Minus 2 minus 0, and of course the gradient would be a half. So the gradient of the line OP is a half, and we can see it has a y-intercept of 0. So I can use this format, y equal to mx plus c, and c is 0 and m is a half. So that's my equation 1. So I have the equation of my first line. Now I need the equation of the second line. What do I know here? That it's perpendicular to OP. So the line 2, I've just called it line 2, is perpendicular to OP. So if this gradient is a half, that's OP's gradient is a half, then the gradient of the line I'm looking for must be -2, since the two lines are perpendicular. And that line also has a 0.50. So that's all I need for an equation of a straight line. A gradient and a point. So I'm going to use this format, gradient point format. So y minus y1 is equal to mx minus x1. Therefore, y minus y1, which is 0, gradient is -2x minus x1, which is 5. Simplify this equation, you get y equal to -2x plus 10. Now I have the equations of my two lines, and now I can solve them simultaneously. So I substitute equation 1 into 2, I get a half x, replace y with a half x, equal to -2x plus 10. Solve for x by multiplying both sides by 2, get rid of the fraction, get -4x plus 20. Solve for x, you get 5x equal to 20. Divide both sides by 5, x is equal to 4. And that's not the end, because the point of intersection has an x coordinate and a corresponding y coordinate. So if x is 4, I can substitute this into 1 or 2, but 1 looks easier. So to find y is half of x. So half of 4 is equal to 2. Therefore, point P is 4, 2.